Hello everyone, today we are going to touch on some of the basic tools and functions for drainage design in your RoadEng project. Feel free to engage with us using the GoToWebinar panel to send your questions, and if you're watching this video on YouTube, leave your questions on the comment section below and we will get back to you shortly. So it is worth stating that drainage has an impact on the road themselves, the ecosystem, the environment, and the landscapes that surround them. And when we don't account for those drainage and design properly, we can have a whole bunch of rather negative effects in those things. Whether it is increasing the sediment in nearby creeks, causing side slopes to erode and making our roads unsafe, to the damage itself that can happen when a road has a wet prism, like we can see on the left side of the screen, to substantial landscape impacts like landslides or switchback failures, or just the impact that changing the water flow and accumulation can do to a landscape. And an interesting photo we can see here on the right side, the contrasting growth rates on either side of the road. That is the impact that creates the change in the water flow that the road has created there. So today, in today's webinar, we'll be talking about different drainage functions inside RoadEng. Now, there are a lot of functions that are available on both sort of a more basic side and more in an advanced function side. And we are going to tackle some of those today. We are going to take a look at minor culverts and cross drains and how to account for them in your projects, talk a little bit about different elements of the cross-section and how they can impact drainages such as the ground or the inslope and outslope, as well as inclusion of ditches in the cross-section. Also, we are going to take a look at an independent ditch profile, as well as create an off-take ditch or channel alongside your project. So we are going to tackle the items that are marked in green here. And there are many other items that we are not going to cover today, such as major culvert replacements, bridge abutment design, drainage area calculations, and rock spill apron or armoring. We will include links for these for videos to those specific, more advanced functions with the follow-up email that will come after this webinar, as well as this YouTube video for you to check it out. And with this brief introduction, I'm going to pass it over to my colleague and our resident webinar expert, Matt Dickey. Over to you, Matt.
Thanks. And I'll share my screen here. Let's. All right, so my plan today is to start out really basic, and we're gonna add more and more to our design as we go. With that, some of the stuff, especially on the the front end of my presentation here, is stuff that it's even a step back from our default settings. So a lot of the stuff is accounted for in our default settings already, like crown and ditches and stuff like that, but it's still worth just understanding where those things are stored, how you can apply them in the software, and how they interact with your project. As Patricia introduced, I'm not going to spend a ton of time going into the the why or the theory or on a lot of this stuff, and there's a bunch of things I'm not planning to show that relate to drainage and road design. Of course, drainage and road design are synonymous with one another, and it's a big part of all the considerations we make. And with that, when we send out the link to the recording, we'll also send out links to some previous content that is cover some of the stuff that we won't cover today if anyone's interested in it. So I have a road that's somewhat designed to begin with here. And we can see here, that's not much of a road prism in my cross section. We'll just kind of look at the 3D view and look at what's going on. So I'm going to kind of incrementally try to add things to this, kind of work from the center line out and from the top of our road down, and kind of account for different considerations. So if we're looking at the center line of our prism here, if rain falls on our road, well, one, the roadway is flat, so there's nothing kind of pushing that water off to the side for us. And two, if it is a weak subgrade, well, it may rut, which traps even more water on our road surface. So right off the bat, from the road top perspective, let's add in a few things to consider. So I'm going to go up to our template editor, and here we've got this really generic cross section that we're looking at that is kind of that trapezoidal approach, no ditches, nothing. But again, our defaults have a lot of this stuff already in them. So I'm going to create a new template, and I'm going to just call this to improve. So if we want to add surfacing onto this road top, we can. So I've got the resource one template component in here, so I can double click that, and we can come in here and we can say, well, let's add some surfacing on our road top, and we can add that depth, and that gets included in here. So I'm going to stick with that here. I'll just copy and paste that off to the right. And this is a gravel road that I'm doing. We could add a separate surface in there if we had different gradation requirements. And if it was something where we required paving, well, we'd select a different component that has a pavement structure in it. And there's all sorts of other options in our e-library. So that surfacing stuff fits in the template component. But to add a crown in here, we are going to do that at the template level rather than the component level. We'll come in here and we'll add that in. So I'm going to go with a 4% crown. And there we are. We can see that it's now going to, if water comes down from the sky and lands on a road, it's going to end up off to the side. And we've got that surfacing to help prevent rutting. So let's hit OK. And nothing changes yet because we haven't assigned that new template. So we'll go assign and we'll add that TI template to our whole road. So the next thing on our list of things to consider is, well, we've got this crown that's going to help push water off to the side, but we need somewhere for it to go once it gets to the side, or at least somewhere to store that water. So the next thing, real obvious thing to tackle, is ditches. And aside from just taking the water off our road top, they also give us capacity to intercept overland flow or subsurface flow from upslope. So here, any water that lands uphill here is going to, as is, land on the slope above, come down, hit the road and we'd have road or water and channeling on our shoulder rather than just being stored off to the side in a ditch. I'm gonna jump to somewhere flatter here. Oops. I'm gonna hit undo. I hit the wrong button. So I'm gonna jump to, say, there-ish. And up here on this kind of terrace where we've got a lot flatter topography, that ditch is going to do something else for us too. So let's come in here. We could just steal the ditch from one of these other templates that we have on the go. We'll go onto the eLibrary. We're going to grab our components. We'll go into the ditches and we'll start with this one here. So ditch 1. And just worth a note, there's a bunch of other ditches that do different things that we could use in place of this. I'm going to take that, I'm going to paste that. I'm going to configure it to match what I'd like. So I'm going to set my depth. I'm going to set my bottom width. For those of you that like a V ditch, we could easily just put a bottom width of 0. And I'm going to set my slope to be 2 to 1. And we'll do the same on the other side. And rather than plugging those numbers in again, I'll just paste it onto the other side. So aside from that nice functionality of just giving us somewhere to intercept flow and keep that away from our road top, adding a ditch does another thing for us, and that is it creates this extra cut. So we can just take the cut material out of there and flop it over to build up our subgrade, and that's going to let us increase our embankment height, which is going to help with drying things out in the sun. And if we're living in a temperate climate or somewhere where it gets snow, it's also going to help with snow removal. So the snow that gets bladed off has somewhere to go. It just doesn't fill up a trench off to the side that isn't going to function. So since we're changing the template that's been applied, we'll see the changes take place for us. And our mass haul is all out of whack. So just to get that road shifted up, like I said, it would make sense to, I'm going to just optimize that real quick. And while that wraps up here, the next thing kind of worth considering is we've got this prism that has a ditch now. We've got somewhere to store that water and let it flow against our road, but eventually we're going to want that water to still flow away from our road. So with that, we are going to want to add culverts. So we want to move it from one side to the other. Well, culverts are the way to go with that. And just a sec here, while that. So we're shifted up as promised. And I'm going to use somewhere benign here to place my pipe. So where do we want to go? So I guess that's as good a spot as any. And while we're, I guess, talking about drainage, a nice tool to help us kind of figure out the lay of the land on these less than rugged landscapes is to exaggerate our scale. So let's see what we have on the go here. So we're at a low point. If I decide to put my pipe in there, I can. Now it's not obvious right away where I want to put that. So one thing that we can do is, well, we can show our ditch profile. So these templates have template codes. Our ditch inside is DI. So let's add our codes for ditches. And another kind of nice trick to tackle things like this, where it's really subtle where the low point is if we go up here, we can turn on our, where are we at? Vertical IPs at curves. And I am going to add in an extra attribute that includes my low station. So the low station's at 1790. So there we are. And I'm going to add in my culvert. So I just plop that culvert in. And with that, there's kind of some other stuff going on here. So I've added in the culvert, and let's just see here. I'm gonna just make this a little more transparent. And I'll make this a little transparent too. So this culvert lets our water move from the high side to the low side. But in this particular case, we have a problem and there's nowhere for it to go. So the next thing on my list of things to cover is, well, an offtake ditch. That's not the only solution here. We could very easily decide, well, we want to keep our ditch going at a different grade than the road. So we don't need a culvert there at all. It just goes back to here, and we'll cover that in a moment. And then the other thing is that I haven't mentioned right at the start, but I should have. Where you place your road also influences kind of the drainage requirements for your project. So it might just be as simple as, well, there's a more favorable spot in another location where I don't have to worry about crossing this boggy section. So, and then I should mention too, before I do the offtake ditch, a lot of the time, well, let's go with something like that. You choose culvert locations where the water can get moved to the other side of the road and transported away. But let's focus on this one here and kind of lean into the more complicated side of it. So we'll tackle our offtake ditch first. And that offtake ditch is basically going to be designing a channel. So our project here today is a road project, but we've got lots of users that use RoadEng for things other than roads, and one of those common uses is folks that are just focused on drainage design. So you can absolutely design channels and ditches independent of a road. We'll do that as an off-take ditch here now. For me, I'm going to do this as another alignment. Click Add Horizontal Alignment. I'm going to do a new alignment. It's just going to start as a single point. It's not going to be a road, so I'm going to change my template. And it's going to be something that looks very similar to that cat track template that I had to start. Except it's not going to be as wide. I still want to make it wide enough to get in and out on it. So that's going to be my channel. I'm going to assign that to my horizontal alignment 2. And if I'm being really good about keeping things nice and tidy, I'll even give this a name. So I'm going to take this, I'm going to move that over to here. I'm going to extend that out along here. Now I want to see this existing road in my cross section and in my profile. So let's merge this first of all. I also want to see this channel that I'm designing as its own surface too. So we'll do that. And we're going to come up here, section options. We're going to make it so we can see that other surface. And we're going to make it so we can see that other surface here as well. I'm going to drop this down to the bottom here. And that is more luck than anything else that I happen to get that in a good spot, but most of the time there's probably going to be a little bit of wiggling around here to make sure we have that where it makes sense. So here, for example, I can see it might make sense to push my ditch further out. And let's see what we've got here. And there we are. And I'll just lop off the end of our off-take ditch after station 50. So we've designed this off-take ditch to make sure we have somewhere for our water to go to get away from our prism. So that's one option for what we can do to tackle this situation where there's nowhere for our water to go on the other side of the road. Let's switch gears. So let's delete that. And I don't want this to be merged anymore. So instead of ditching that away as a separate alignment, let's consider just grading this ditch separate from our road grade so we can get that water back to here without needing a culvert. So we're going to go from station 1790 back to somewhere around here, so 1545-ish. And again, we're going to use another alignment, but we're only going to use it for our profile. So we've got that. I'm just going to duplicate this so I have a target in the same general area. Oops, and I don't need any geometry here, so I'm going to just make that just a center line. And we are going to, I'll get rid of the portion of this that we don't need. So I don't care about the first 1.5 kilometers. And I don't care about the last, well, anything after 1790. So that's the portion that I'm interested in. Now I'm interested in this alignment to represent my ditch. My ditch depth default was 0.9. So let's just shift this thing down. And let's grade this back. So this is just acting as a line. Now I'm not going to keep it. Let's try to keep it at there, 0.7. And we'll shift this up. And we'll jump back into this one. And we're going to create a new template that references that. So in here, we're going to use what we had as a default to start. But we're going to use a different ditch. We're going to use this ditch with a vertical tie. We're going to change our settings to be reasonable. And so the big thing that we're going to do here that's different from our standard ditch is we're going to connect this ditch depth to that other feature. So we're going to click this, we're going to click that. We're connecting to horizontal alignment 2. We're going to use the center line for that to set our elevation. So now, wherever we put the road, that ditch elevation is set based off horizontal alignment 2. We'll do that on the right. We'll hit OK. And we're going to apply that template. So let's go 1545 to 1790. And we can see that instead of having that ditch that follows our road grade, now the ditch is independent and away we go. Oh, and I just see something in my 3D that I don't like. Let's remove that. So there we are. That ditch goes deep and gets our water way back to here where, well, we've got a lot better relief to get that away from our prism. And here it turns out we still need a culvert, but at least we have relief to move that away once it goes through the culvert. So there's kind of on the spectrum of things that we're going to cover today, that's probably the most most technical. It's just the ditch profile is independent of your road, and you can kind of leverage that to get water to move where you'd like. And then the next thing on our list, and I'm kind of circling back to stuff that we've already covered, but I said that most of the time we want to have our road crowned to move the water off to the side. That isn't always the case. And sometimes, rather than having the road split front load either side, it's beneficial to have an insloped or outsloped road. Now, there's a few different ways we can tackle that insloping or outsloping. One is we can create an entirely different template that that has a different crown applied to it, where the crown is negative on one side and positive on the other. The other way we could do it would be to take the overrides and override our crown for different sections. Or if we're using a gravel road template, we can grab our resource 2 component, which is going to automatically flip direction depending on the aspect that you're on. So we'll go with the latter. Once again, we're going to use this as our starting point. And we'll go insloped. So the workflow is the same for both. And we'll go in here and we're going to grab our resource 2. And we'll shift this up. I'm going to just change a couple things here so it looks similar. So matches. But the big thing here is going to be that this is going to be set to 0. So be outslope, it's going to set to 0, so it's going to inslope instead. We'll get rid of that other road. Copy, paste as right. So there we are. And just if we were to flip that around, it would become an outsloped road. So we've got that. We'll hit OK. So we'll apply that to station 700 from 355. And the reason we'll do that here is just to give our ditch a little added capacity if it fills in with material. So rather than only having road surface that goes up to that height, it's going to continue on to a little bit higher here. So if our ditch fills in, we've got a little bump in capacity from allowing flow onto the shoulder of our road. So that is 355 to station 700. And what did I call it? In slope. And there we are. So we can see that's tilted in. And in this case where we've got that switchback, on this side it's tilted that way. On the upper side it's tilted that way without having to worry about it. So with that, that is the kind of the topics that I hope to cover. Just as a quick recap before we open it up for a few questions. So we've taken something that was basically a cat track or a trench, so no crown, no surfacing, no ditches. And just by adjusting the cross-section template geometry, we've added things like surfacing, the crown, ditches. Then we took that a little further and we had an independent ditch. So the ditch is following our road as in attached to the prism, but the grade is at a different slope than the road grade. And we also looked at, well, maybe it makes sense to just treat that as its own alignment and taking that flow away with an off-take ditch, getting it further away from our prism and putting it somewhere where it's appropriate. And then we circled back and we tackled the in-slope, out-slope, and using that Resource 2 template to do what we'd like. And of course, it was touched on just in passing, but we've added in a culvert here where it makes sense to add a culvert to move that flow from one side of the road to the other. I didn't talk about this probably as much as I should have, so just before I wrap up, we can double click, we can change our diameter, we can change our structure type. If it makes sense to add a sump or something like that, we can override our ditch depth on the inside. We can change it from auto length to setting that length tabularly. We can control the skew. I'll change my skew here to be entirely perpendicular, or we can make it even more. We can change our grade. We can change the detachment point. It's all really flexible and easy to work with. Yeah, so with that, we'll open it up to some questions and
excellent. Thank you, Max. We do have some questions here, so let's start with this one. With the independent ditch as separate alignment, how does it display in the multiplot?
With it being an entirely separate alignment?
Yes.
So the off-take ditch where we did it as a separate alignment, it would be just that, an entirely separate alignment. And if we wanted to include it in the multiplot, we could show it in the plan view just by displaying it. And of course, I've deleted it, so sorry about that. But then the other thing to do, if we actually wanted things like our cross-section geometry to show up, we could just do it as its own separate alignment with its separate multiplot, and then connect the two multi-plots outside afterwards. Yeah, so hopefully that answers the question. Separate alignments are separate and treated as such, but they can be displayed in the plan view. And cross-section view of the current alignment and plant profile view, but to get like the cross-sections along that independent off-take ditch, then you're looking to do that as a separate one.
Awesome. Okay, we have another one here. Can the culvert sump move with the culvert inlet with setting the skew? Maybe I. Do you want me to read that again? Maybe I didn't pronounce quite well. Can the culvert sump move with the culvert inlet when setting the skew?
Oh, okay. I think
Sorry.
I've. Oh, no problem. Let's see if I've got somewhere that I can throw that in here. Let's dump in a pipe. And that doesn't look very nice. So let's change that just because it's going to bug me if I don't. And I'm going to kind of force this to be deep. Make it a little funny. And the answer is no. And it's hard to see. I'll make it, aside from just deep, I'll make it wide too. All right, so looks funny intentionally. So here we can see with that little bit of a skew, the sump is applied at the station. So the short answer is not directly. We could mess around with our offsets, but it's still going to be relative to where the pipe is aligned at the station. Now, if you want to move that, you absolutely can, but the way to do that is going to probably be easiest in your overrides. So just change the depth, figure out where that inlet would like to be, where you want to start the taper, and assign the ditch depth as an override. It's not directly connected that way, but yeah, it's just a couple seconds to go in here and say ditch depth on the right side. Add, set your station, and set your depth to what you'd like to get that transition out. So hopefully that answers your question. But yeah, it is set relative to the centerline station where the culvert's added.
Okay, great. Now we have another one here. If that one is finished.
Okay.
Yeah, okay. For the cross drains, I find they have weird sizes in Auto. Is it possible to adjust them to round numbers?
Yeah, in just a sec. So the your defaults for diameter, they might just be that our defaults don't match up with kind of common sizes in your area. You can change these. Oops, I'm in the wrong station. You can change these by saying, well, I always want to start with a 600 mil culvert for my cross drains. So we can add that in and we can hit save as defaults. And then when I add in something else on my design, it's going to be that 600 mil pipe. So that is diameter. The other side of it is length. So we'll see here that I've just, and again, I've got that set to auto. Let's change that to something like that. So here, auto is sizing my pipe. And I've got this like 5 1/4 and 5.64. So that's not going to round it up to any particular length, but we can turn that off once we're close to being done and say, well, I want to have this incremented in closest half meter, and there we can set that. So Yes and no.
Okay. The next question says, can I also get a bill of materials for my culvert?
Yeah. So here we've got 2 pipes added in so far. I'll just create a data table. So I want to see this information reported wherever I've added a pipe. And the information that I'm interested in, we'll change these columns to be culvert diameter, and let's go total length. So that's the important stuff to order, and we can see, well, what we're ordering for diameter and size. Yeah, so I think that answered that one.
Great, thank you. Next question. Sorry, can you include the earthworks for your off-take ditch with your main alignment?
I wish I didn't. I wish I didn't delete that. Yes, but of course I've already deleted it. So bear with me here. And so we're gonna pretend that off-take ditch was still there. And if I wanted to account for the little bit of a blip in my material surplus, I could go up into my assign by range. I could go into my pits. And usually when we think about pits, we think of, well, a borrow site for dealing with a material deficit, or a spoil site to dispose of material. But if we want to force an addition of material at a fixed value in here, we can. So we could say, well, that was at 1790. That's going to be a borrow site. And if we knew how much material that we excavated on that off-take ditch, we absolutely could. We could just say, well, we've expect a blip of 1,000 cubic meters from that, and we could assign that, and then that material gets incorporated in our movement. Yeah, the practicality of it will depend a little bit on the scale of your offtake ditch. If you're just ditching with a mini, you're probably not hauling that material back there. So if you're worried about costing when you're designing the offtake ditch, you can allow side cast and account for that material just being disposed of adjacent to the ditch. Yeah.
Okay, fantastic. I think we have time for one more question. Is it possible to show slope vectors for the finished road surface?
Sure.
Better visualization of flow.
Yeah. So that is I'm going to use that as an excuse to talk about some stuff that I just kind of, well, I didn't even really discuss much on. If you have something like this, where we've got our crown, and it's the default crown, but it's applied on a relatively steep grade, it's just worth noting that when the rain hits that, it's not going to hit your road and go off to the side perpendicular to your road. It's going to follow the fall line of the combination of the grade and the crossfall. So with that, you're on steeper grades, you have a longer flow path of your water on the road top. But it's moving away and it's getting pushed off. Now the flip side to that is if you have a subtle crown and you're on something that is 0 or close to 0, so often becomes apparent on the crests of hills and the sags and valleys, and you get a lot of potholes, and that is that things get flattened out and the water doesn't get pushed away because there's not enough really crown to move that away in a timely manner. So yeah, that was more just me talking about something I should have talked about earlier. Let's take this road. We're gonna save it. I just want the current surface. So we can't do it right in location, but we can really easily add it into a graphic from a terrain file. So let's go with that. And I'm not worried about all this other stuff. I just want that, and we'll edit in terrain. All right, so there is our road surface in terrain. And if we'd like, we can go in here and we can turn on our surface and we can turn on slope vectors. And now we can see the direction where that water flows. And so here, that's our road top. This was where we have that inslope being applied. So all the water hits the road, gets pushed off to the side, hits the ditch, and moves down the ditch. Yeah, and we can kind of cruise along here, and we see like that's our road. And we've got our crown, and that slope vector isn't perpendicular to center line. It's a combination of the grade from our road and the slope from our crown. So yes, and we could take this and we can add that in as a background. So hopefully that answers your question. Yeah, pretty. I like that question.
Okay, thank you, Matt. And I think we are done with the questions and ready to wrap up.
All right.
Here, so
Perfect.
thank you,
All right.
everyone. And
Thanks,
thank you,
everyone.
Matt. Bye.
All right. Thanks. Bye.